Good afternoon, everybody. So, after we have discussed about both the reflective and formative measurement model, so now it's time to come to the structural model assessment. We assess the structural model. Before I start, I would like to explain you some of the things related to the structural model assessment. First, as I say that once the construct measures have been confirmed as reliable and valid, so the next step is to assess the structural model result. And this involves examining the model's predictive capabilities and the relationship between the construct. So before assessing the structural model, we must examine the structural model constructs for collinearity. The reason is that the estimation of path coefficient in the structural model is based on OLS regression for each endogenous latent variable on its corresponding predecessor construct. Just as in regular multiple regression, the path coefficient may be biased if the estimation involves insignificant level of collinearity among the predictor construct. So, what are the steps for structural model assessment? We'll have 5 steps. So, after checking for the collinearity, the key criteria for assessing the structural model is first, as we said, collinearity. Second, the significance of the path coefficient. Third, the level of the R-square values. And 4, the F-square effect size. And number 5, the predictive relevance of chi-square or chi-square effect. So, to assess collinearity, we start first with collinearity. We should apply the same measures as in the evaluation of formative measurement model indicator, i.e. we use the VIF values. To do so, we need to examine each set of predictor construct separately for each subpart of the structural model. So, hence we need to check whether there are significant level of collinearity between each set of predictor variable. I'm going to use the same model that we used before, the corporate reputation extended model for that, and we should note that we have to consider VIF below 5 among the predictor construct as an indicative of non-serious collinearity. If the VIF is above 5 among the predictor construct, then we will say that the collinearity is too high. If collinearity exceeds this threshold, we should consider eliminating the construct or merging predictors from multiple construct into a single construct, or creating a higher order construct to deal with this collinearity problem. So I'm going to start with the SmartPLS. I will go here, same like before. We will have the extended model. It's loading, okay. Then I will make it smaller. Okay, so that we can see all the construct. So first we will run model, calculate, so start calculation. Then we have this. Now our model, you can see is all the values are here. Okay, and I will come here. So first thing that we say that we are concerned about is collinearity. So I come and click here, collinearity statistic, VIF. So I have my result is already there, and you can see the VIF values for each indicator, and here for each construct. So you can see for the dependent variable, the VIF values for the independent variables, attractiveness, corporate social responsibility, performance, quality, all of them are less than 5. Hence, this suggests that multicollinearity is not a problem. You can see here the VIF values for also the other independent variables that need to be examined for multicollinearity are also less than 5, indicating that multicollinearity is not a problem either. Before, if you remember, we have done this for the indicator, and this is for the construct. So now once we ensure that we don't have the problem of multicollinearity, we go for the next step. Next step is what we say is assess the significance and relevance of structural model relationship. So after applying the PLS algorithm, the estimates are obtained for the structural model relationship or the path coefficient, which represent the hypothesized relationship between the construct. And before examining the size of the path coefficient, we will first examine the significance. How we do that? We must run first the bootstrapping option. So I will come back here. So I click calculate, bootstrapping, and here 5000 recommended, here complete bootstrapping, and I put calculate. It may take a long time, so we will wait for a while. So it is already now the bootstrapping already finished, done. So we can see here in the model we have also this bar here. It can help you. You see the inner here, they are p-values, so we can change them and put them the statistics if you want, and you can see them already changed. You put them p is already here, 0 significant, right? Or you want to put them in t values and be based on t is also. Outer model also, they are in p values, so we change them also. We can change them as t values if you want, and you will get here t statistics, you know. Or maybe you want to put them outer weight loading and p values also can. So it depends on what you want, you know. And here the construct, they are R square here, but also maybe you can put them as composite reliability. It will be changed, but better we give them R square. So this is the things that I want to share with you, that you can have all the I say the result, and you can change change them based on your preference or your need. So here also, if I click here, show defaults, it will give more options. So I will leave for that. Now we go back to our table and we see here the result of the bootstrapping. So you can see here we have some of the values are not significant, but it is important to assess the relevance of the significance relationship, and path coefficient in the structure model may be significant, but the size may be so small that they do not justify scholarly or managerial attention. Means even it is significant, maybe the effect is 0.000, something like that. If one path coefficient is larger than another, its effect on the endogenous latent variable is greater, of course. More specifically, the individual path coefficient of the path model can be interpreted just as the standardized beta coefficient in OLS regression. So these coefficients represent the estimated change in the endogenous construct for a unit change in the predictor construct. So looking at the relative importance of the exogenous driver construct in predicting the dependent construct, let's say perceived competence, okay, we see that consumer perception of the company quality of the product, service, qual is how much, competence, qual to competence 0.430 is the most, I think, important, followed by, if I'm mistaken, performance, yeah, 295, 0.295, yeah, here. Then we have, in contrast, attractiveness and corporate social responsibility influence COM very little, 0.05, and attractiveness is 0.086. So in combination with the other predictors, so attractiveness and corporate social responsibility are more important in predicting the company likability. So you can see attractiveness to like is 0.167 and corporate social responsibility to like is 0.78. Okay, and corporate social but the most important predictor of like is qual, which is 0.38. So COM has no impact on customer loyalty. The p-value is more than 0.05, is not significant, but somehow it has a meaningful impact on CUSA, which is 0.146, and it is significant at 0.05 significance level. So that what we have done with this. Now I go back here, and we should now understand the direct and indirect effect, because this will affect quality effect, COM effect, CUSA effect, customer loyalty. So it's like here there is, an indirect effect between this and this, or this to this. So researchers are often interested in evaluating not only the construct direct effect and another, but also its indirect effect via one or more mediating construct. So the sum of direct and indirect effect is referred as the total effect. And if we come back here and we click here, we have total effect. So thus here we will have all the total effect. The finding also shows that qual has a strongest total effect on loyalty, which is 0.248, followed by corporate social responsibility 0.1, corporate social responsibility 0.105, then attractiveness 0.101, yeah, and performance 0.089. So if I click here confidence interval, so you have other information that could be interpreted here, confidence interval. So I'm not going to discuss all these kind of things. So now I will click on the first step, which is the level of the R-square values. So I will go to the R-square, and you can see here the R-square values of COM is 0.631, customer loyalty is 0.562, then we have like is 0.558, then all can be considered as a moderate. In contrast, we have the R-square value of CUSA, which is 2 or 0.292, is rather weak. So we have 3 moderate, 1 is weak. Another step, number 4, is the F-square effect size, which is this, the F-square. The F-square, the effect size. So the F-square effect size is a measure of the impact of a specific predictor construct on endogenous construct. In addition to evaluating the size of the R-square values of all endogenous construct, the F-square effect size should be reported. The F-square effect size measures the changing in the R-square value when a specified exogenous construct is omitted from the model. It is used to evaluate whether the omitted predictor construct has a substantive impact on the R-square value of the endogenous construct. So the F-square effect size is range between 0.02 to 0.15, consider is small. If the F-square effect size range between 0.15 to 0.35, consider as medium. If the value is above 0.35, then consider as large. So let's look at our result here. It seems like that we have the highest value is 0.412 is the F-square effect size for the predictive value of COSA on COS-L, then followed by, or how to interpret this, we can say the 0.412 indicate that COSA has a large effect in producing the R-square for COS-L. In construct we have I think here, yeah, like has 0.138. So 0.138 is the f-square effect size for the predictive value of like on cos-L. And we have another one which is like dan, cosadan, com. There is no effect, is 0. Then finish. So you can see we have two are very important or has moderate to a large effect, one has no effect. Now number 5 assessment is blindfolding and predictive relevance of chi-square. So chi-square, in addition to evaluating the magnitude of the R-square value as a criterion of predictive accuracy, researcher also should also examine the chi-square value, which is an indicator of the model out of sample predictive power or predictive relevance. The chi-square measures applies a sample reuse technique that omits part of the data matrix and uses the model estimates to predict the omitted part. So when PLS SEM model exhibit predictive relevance, it accurately predicts the data point of the indicator in reflective measurement model of a multi-item as well as a single item homogeneous construct, or the procedure does not apply to formative homogeneous construct. So for SEM model, chi-square value is larger than 0 for a specific reflective homogeneous latent variable indicate path model's predictive relevance for a particular construct. Chi-square values of 0 or below indicate a lack of predictive relevance. So as a relative measure of predictive relevance, values of 0.02, 0.15 and 0.35 indicate that the exogenous construct has a small, medium and a large predictive relevance for a selected homogeneous construct respectively. So also the chi-square values can be calculated using two different approaches. First one is the cross-validated redundancy approach, uses the path model estimate of both the structural model and the scores of the antecedent construct and the measurement model or the target homogeneous construct. An alternative method is a cross-validated communality approach. This method uses only the construct scores estimated for a target homogeneous construct without including the structural model information to predict the omitted data point. So it is recommended that using the cross-validated redundancy as a measure of chi-square, since it includes a key element of the path model, the structural model, to predict eliminated data point. The blindfolding option is only used with homogeneous constructs that are measured reflectively. So we go here and we click on, I go to the extended model, then calculate and put blindfolding. So after we got this result, we are concerned about the result here in this column. We have chi-square equal to 1 minus SSE divided by SSO. So you can see here the path model, for the path model, the predictive relevance chi-square for cos-L is 0.413, which indicate the model has a large predictive relevance for the construct. Remember, small is 0.02, medium is 0.15 and large 0.35. So it's 0.43, which is large. And also all other endogenous reflective construct in the model have chi-square values considerably above 0, all of them above 0, which provided support for reputation model predictive relevance for the 4 endogenous construct. So with that, we have done all the necessary assessment for the structural model, and we will discuss in next videos coming soon on the moderator effect and the mediating effect and high order construct. So I will see you soon then. Thank you very much.